Good evening everyone, I am Mr. Ish. Thank you for joining me for this video. We're here looking at vector application where we are going to put what we have learned into practice. We have a question here, a glider. You know, a glider, it basically gets its speed and then it maintains it by means of the wind. It goes in the air and then it stays in the air and it just glides. A glider is gliding at 50 miles per hour heading due east. 15 mile per hour wind is directed at north 45 degrees west. What is the glider's resulting direction and speed? We have a bit of here directions being mentioned in these various ways. We have to understand what that means. Let's talk about the glider first, and then we'll talk about the wind. We have to write these in their terms of their component forms, magnitude and direction. When we're talking about gliders heading due east, you know the compass is made up of north, east, south and west. Anything which is heading due east, which is towards the right, is always 0 degrees. So when something is heading due east, we're calling it 0 degrees. So we know that with regards to the glider. What about the wind? Wind is directed north 45 degrees west. Look at north and then go 45 degrees west of it towards the left, and this right here will represent the direction of the wind. North 45 degrees west would be 90, because north is 90. Each of these quadrant angles are 0, 90, 180, 270, and you adjust accordingly. North 45 degrees west is 90 plus 45, and we have 135. So we now know that the wind is 135 degrees. We basically have everything here we need to actually do this question. The glider can represent like a u vector, wind can represent the v vector. The glider has a magnitude. The magnitude here instead of length is speed. The glider has a speed of 50, that's a magnitude, and we know its angle east 0 degrees and sine 0 degrees. That's right, the component form of the glider, the magnitude and the direction. For the wind we know the magnitude. The magnitude is 15 and we have the direction cosine 135 and sine 135. This right here is now you representing everything here in the component form. You have the magnitudes, you have the directions. These are the speeds and this is the direction. But this is the difference between speed and velocity. Speed is this item only, a single dimension. Velocity is everything here you're seeing. The speed with the direction. The speed with the direction is velocity, which is why velocity is a vector. Speed is just a single quantity, single dimension, therefore it's just a scalar. Anyhow, let's open this up. Cosine 0 is a 1. 1 times 50 is a 50, right? You're basically multiplying this with this and then that with that for each of these components. Sine of 0, 0, it multiplies with 50, you get 0. Here we can do a good decimal answer. Cosine of 135 is a second quadrant cosine angle, it's negative. We'll multiply that by 15, we get a minus 10.6, so let's write it. And of course this right here will be 10.6 because sine and cosine of any of these 45 degree angles is always the same. You can check it out, 135 sine times 15, you get 10.6. Anyhow, now the resultant is equal to the addition of all of this. You have to add this up right here. 50 plus minus 10.6. 50 minus 10.6, I get it 39.4. Add this up, you get a 10.6. These are now the vector components of your resultant vector. But we have to find the magnitude of that resultant. We'll do this square plus this square root. What will that magnitude of the resultant give us? It'll give us the speed of the resulting glider. How it is affected. We'll do 39.4 square plus 10.6 square and we'll square root it. We get 40.8. Of course the speed of the glider is going to slow down because wind is not going along with it. It is at a certain angle slowing it down. What about the angle of the theta? It's always equal to arctan, the y component, which is 10.6 divided by 39.4 degrees. So let's do this on our calculator. We'll do 10.6 divided by 39.4 inverse tan, 15 degrees. And that right there is our angle, 15 degrees. What else can we say about this? We know originally the plane is going 0 degrees and the wind is opposing here. So somewhere in between, your resulting direction of your glider is here. We can say 15 degrees or we can say north. Everything is usually presented with regards to north. And how many degrees are we towards the east of that? North, it's 90 minus 15. It'll be north 75 degrees east. You got to be able to convert this form into this form and everything with regards to reference north. When you have directions here with this, you convert them with regards to reference north. It'll be 15 degrees will be north 75 degrees east. 90 minus 75 will give you that 15, and there it is. So this glider is now having a speed of 40.8 but is having a direction of 15 degrees from 0 or north 75 degrees east. And this question has been completed. Alright, last question. We have vector u is directed at south 15 degrees east. It has a magnitude of 10. We're not worrying about the units. Vector v is directed due west. It has a magnitude of 20. Again, we're not worrying about the units. Find the resultant. Well, it's not hard. Let's put u and let's put v. We know each has to be written in their component form. The magnitude of u is a 10 and it has a certain direction. V has a magnitude of 20, it has a certain direction, and again we have to look at everything here with regards to compass directions. North, east, south, west. We know vector u is directed south 15 degrees east. You look here south and then you look in the direction of east by 15 degrees. So you're doing south, which is 270 degrees. You do 270 plus 15. Why do you add 15? Because you're going in the direction of 360. So it's 285 degrees. Vector v is cosine 285 and then sine 285. So remember that again. South here is 270. We're going 15 degrees east of it towards 360. So you add 15 degrees. Anyhow, vector v is going due west. Due west is what? 180 degrees because you're exactly towards the left. Remember 0, 90, 180, 270, 360. It's 180. Alright, there it is. We have all the components. Now what we have to do, of course, as you know, we gotta multiply it. These components, we'll bring out our calculator. We'll do 285 cosine times 10. We get it 2.588. Now we'll do sine 285 times 10. I get a minus 9.7. I'll round it up. Let's do this right over here. Cosine 180, well that's easy. That's a minus 1 times 20 is a minus 20. Sine 180 is a 0. Add these up. These will give you a resultant components. Minus 9.7 plus 0 is a minus 9.7. That's easy. Now we'll do this. 2.588. 2.588 minus 20. We're getting here a minus 17.412. To make this more meaningful, you can even graph it out. U is directed south 15 degrees at 10 and vector v is twice as big. It's large because it's 20 versus 10, so it's twice as long and it is directed due west. You know, a resultant will be somewhere more closer to this stronger, longer vector than towards that, but it'll be somewhere an angle between these two. Anyhow, we can find the magnitude and you'll do this square plus that square and square root. The negatives will go away. We don't even have to worry about the negatives. We'll do 17.412 square it plus 9.7 square and we'll square root. We get 19.9. So it's so close to 20. This 10 had a very negligible application to it. Now let's find the angle of the resultant. The angle of the resultant is this divided by that, inverse tan. Very likely here in the third quadrant, tan is always positive. You'll do 9.7 divided by 17.412 inverse tan. I get 29 degrees, but in addition to 180, because it's in the third quadrant, add it to 180, I'm getting 209 degrees. But I have to write this in the proper form, 209 degrees. I'm going to write this in this form right here with regards to, you either write something with regards to north or with south. Here's my south, here's my north. The fact that I'm here in this direction, I'll do 270 minus 209. I'm 61 degrees away from the south. So my answer here will be south, 61 degrees away, but in the west direction. See, I'm in the west direction, and that right there is my answer. The magnitude of this vector, resulting vector, is 19.93 whatever units, and it is in the direction of 209 degrees or south 61 degrees west, and this question has been solved. If you want to actually graph all of this, you know you got 19.93 and you have this direction right here, or that 209. You can draw your resultant. It should be very similar in length to 20 because 19 is not too far away. It would be in 209 degrees. 209 degrees is not too far away from 180, so your resulting vector would be right over here. And it would be about as long as 20, and there it is. That's your resultant. It has a size of 19.93 and it's 209 degrees from 0, or it is 61 degrees from south towards west. And there it is. We are done with this question. Keep all of this in mind, the application. Everything over here counts. Everything here is important. Thank you for watching. Have a nice day.